Hello everyone. So here I'm making another recording for week 2 Thursday lecture. So for some reason the original lecture does not have audio, so we're having people looking into that. UNSW IT probably need to fix it. So I'm just gonna give you an idea of what happened in Thursday's lecture. So basically, we talked about week's assignment one's schema. So we have a quiz due on Friday night, and we need more people to set up their PostgreSQL server. And in the first half of the lecture, we're going to talk about the database schema for assignment one, which is about football matches. And then we're going to talk through a couple of ER to SQL mapping examples. We're going to talk about how to map subclasses, and after that is more of how we're going to talk more about data manipulation language. So we're going to present how to insert into the database, how to delete from the database, as well as how to update the database. Okay, so let's just start it with the assignment database. So assignment is gonna be released by the end of the week. So, but probably today or tomorrow we're gonna release the assignment. So this is the football. This is a database about football matches. We have football matches. We have teams, we have players, and we also have goals and card. And by looking at it, we need to map these strong entities first. So these strong entities will get their own tables, obviously. And then we'll need to map these relationships. So we got a many-to-many relationship here involves, and we got and for the other relationships, they're all one-to-many relationship. So scored in is a one-to-many relationship. Each match has many goals, and for scored by, each player can have many goals, and each goal can only be associated with one player. And for yellow card and red card, each card is given to one player, and a player can have multiple cards, obviously. Based on my understanding, you got the yellow card and the red card, and a player can definitely get more than one card. And also, in one match, there could be more than one card given in that match. And match has partial participation, so there are matches without any card given. So the structure of the assignment for the first few questions, we have SQL views. Basically, the SQL view questions are we are expecting you to extract insights from the data. So you'll know more about what is a view from week 3 and week 4's lecture. And in the last few questions, we'll ask you to write maybe a SQL function, maybe a PRPG SQL function that produce a formatted text output. So it will be more clear once we know how to write these functions. So you'll learn how to do joins. You need to learn how to use aggregation. You learn how to use string formatting and pattern matching, probably in regular expressions. And you also learn PRPG SQL control flow. So these are the things that you should learn in the next couple of weeks to be able to do this assignment. And we got a couple of warm-up questions, and then from question 4, they're slightly more difficult, and the last two are function questions. They were 30 marks total, and they're due at the end of week 5. And we strongly suggest you start early, because later the questions, because towards the deadline we get very busy and we may not be able to answer you promptly. And one thing that you need to note is that you always need to test on the server, because that is where we'll mark your SQL submission. And we may test you with slightly different data under the same schema, so that if you hard-coded your solution, you'll not receive any marks. And also, this is not a huge issue, but you don't want the query to run very slow. So do be aware of the time it takes to run your query, and also maintain a good coding style, and we'll take that into consideration as well. So based on our analysis, there are about 6 or 7 tables in this database. And before we dive into the SQL implementation, we actually create 2 domains for the type that we use frequently in this database. So basically, if you don't want to declare a value between 0 and 120 all the time, because that attribute is used a lot, and if you don't want to declare something as a varchar and check value in red and yellow all the time in the database, you can create a domain which is basically user customized types, and then you can basically use these types just like you use integers and things like that. So the core entities, matches, and teams, so these are the strong entities. They're very easy to map. And then for one-to-many relationship, there is a one-to-many relationship between players and teams. Between players and team, there's a one-to-many relationship. So we need to ask each player to store which team they're on. And so basically, we don't create a new table for member of, we just put a new foreign key in players table, like this. In player, we store which team they're on. And in involves, it is a many-to-many relationship. We'll have to create a new cross-reference table for it. And it involves is a relationship between match and team, and we need to make a new primary key using the primary keys of match and team, and we need to indicate that these are taken from other tables and they're actually foreign keys in this table. And for Go, the reason why the Go entity is modeled this, it looks pretty complicated here, but it's actually pretty straightforward. So for the Go entity, first we model its primary keys as well as its domain-specific attributes. And then we need to take into consideration the one-to-many relationship Go is in, which are scored in and scored by. So these are all one-to-many relationship. So we need to ask Go to store the primary key of match in its table. And then we need to ask Go to store which player scored Go in the table as well. And that's why you can see in the Go table we have a lot of foreign keys. So the primary key is the Go ID. And then we also need to store 2 pieces of information in which match the goal was scored in, as well as which player scored the goal. So that's why we have 2 additional foreign keys indicating the one-to-many relationship between Go and matches and Go and players. And then we got map the card entity. So it's kind of follow the similar logic. For a card, we first map the card style, maybe red card or yellow card, and the time when this card was given. And we also need to give is a primary key, which is ID. And note that card participates in two one-to-many relationships. So one is with match, the other one is with player. So just like we have stored the foreign keys in Go, in card we need to store in which match the card was given for each card, and we also need to store which player was this card given to. So we store both information in the cards table as foreign keys. So in the card table, we have the primary key, we have the domain specific, we have the entity specific attributes, and then we have two more foreign keys indicating those one-to-many relationships. Okay, and that's the schema for the assignment 1, and you get to play with it once the assignment is released. Let's look at another ER2SQL example before we get into data manipulation language. So this is another ER2SQL mapping example, and in here the ER diagram is drawn in more detail because every entity has a attribute that is underlined and indicating that this is the primary key of the entity. So in this case, we don't need to make extra ID attributes as as primary keys. And just by looking at it, we need to create a tables for employee, department, and project. And then next of kin is a weak entity. So we need to create a table for a weak entity as well. And we also need to create new table for works on, because works on is a many-to-many relationship. And for works in and manages, these are one-to-many relationship as well as one-to-one relationship. So we don't need to create a new table for them. We just need to store the foreign keys in the right place. So for strong entities, it's pretty straightforward. We just create 3 tables. And for the one-to-many relationship between employees and department, because many employees can work in one department, and so we're asking the employee to store the department which they works for. So for me, I work for the School of Computer Science and Engineering, and I'll just put School of CSE here. And for manages, so this is a tricky part. One department is managed by one employee, and also a department definitely has a manager, but a employee does not necessarily manage one department. So it makes sense for us to add the foreign key to the department side, because we want each department to store who is the manager. And what we're not going to do is ask each employee to store what department they may or may not manage. So we add the foreign key to the department side in here. And for the many-to-many relationship, this is pretty easy. We just create a new table for it. We just grab the primary keys from both participating entities, and then we just make a note that those primary keys are actually foreign keys in the new table. So social security number is a primary key in employee, And project number is a primary key in project. And for weak entity, we also create a new table. So basically, for the weak entity, we need to store the primary key of the owner entity. And another thing that is important is the primary key needs to be the combination of the owner entity's primary key with the discriminant of the weak entity. Basically, we got the social security number combined with the name of the weak entity next of kin, and in combination, they become the primary key of the new table. Okay, so that's enough. I hope that's enough ER to SQL mapping, and we're gonna look at one more. And you probably won't need to do this in the course, but um, it helps to know how these things are done as well. So this is an example of how subclasses are mapped in ER diagrams. So basically, there are two ways of mapping. One way is ER style mapping, and the other way is a single table subclass mapping. And in ER style mapping, what we do is that we create a table for the parent class, and then for each subclass, we create new tables, but we don't put the attributes of the parent class into the subclass. So that's just look at an example. So we got person as the superclass, and we got author and editor as subclasses. As you can see that what they have in common is that they all have the text file number, because this is the primary key of person. So we ask subclasses to keep the primary key of the parent class, but they don't really inherit other attributes from the parent class. They all have their own set of attributes. So that is an ER style mapping. And let's just say that in the future, we want to know the author's legal name as well as address. What we will need to do is that we'll need to use the text file number, which is the unique identifier of person. Use the text file number to join it with person, and then we can find the specific row in the person's table, and then we can find this author's address as well as real name instead of pen name. So that's how ER style mapping is done. And let's look at another style of mapping, which is single table mapping. So in single table mapping, we need to map everything into one table, and we need to put every possible attribute from the parent class to the subclass into the table. And the downside of this is that if you're an author, you don't really have a lot of value. You don't have values for the attributes that are specific to the editors. And on the flip side, if you're an editor, you don't really have a pen name, so the pen name is empty. And also, to distinguish what type of person you are in the database, we need a discriminator within the table called type. So we have to say what kind of person are you? Are you an author or are you an editor? And so the good thing that can come up, one thing that's good about single table mapping is that it is good for querying. So let's say that now I want to know an author's pen name. I don't have to do an extra join to know that. I can basically query this giant table and say, give me the real name of the person whose pen name is Peter Parker. So single table creates a lot of issues, and it weakens some entity relationship constraints. But the good side of a single table approach is that it's good for querying. So it's a trade-off between normalization and the querying. Okay, So that's enough about subclass mapping. So most of the times we're going to do the ER style mapping because it gives stronger integrity enforcement and it better preserves the ER semantics. And as you can see that it um, it is more close. It models the ER diagram more closely. Okay, now that we have talked enough about ER diagram to SQL mapping, let's dive into data manipulation language. So the create database statements are data definition language, and here we're going to play with data manipulation language. So from the week 2's practice exercise, I hope you have already learned how to drop and create a database. And PSQL allows you to connect to a database. And today we're going to learn how to insert, delete, and update cells in the database. So I think this part you already know how to do. So before you do anything, you need to create a database. And afterwards, if you don't need it, you can drop it using dropdb. And PSQL allows you to get into the PostgreSQL shell where you'll find a lot of useful operations like listing all tables and listing specific tables structure and running scripts within the shell. And also you can list all of the databases under your current PostgreSQL server. Okay, one thing you need to note is that SQL statements, they are terminated by the semicolon. So if you don't wrap it up with semicolons, it will wait for you to complete that statement and it will look like this instead of this. And we'll see more of this when we're actually doing a demonstration. And let's look at this exercise, and we'll probably play with a slightly more interesting database in VXDB02. So here we're going to create a new table called R, and then we got X and Y and Z, and then X here is the primary key. And how do we insert into this table? Well, we use the insert into table syntax. We need to specify which table is it, and we need to specify the values separated by commas. Let's look at a more interesting example, the mood database. So we have already prepared, let's look at, on the left hand side, we can do a demonstration. So let's start a server and see what databases are there already. Let's drop this database and recreate them. Let's drop the mood database, drop the BS database. Okay, so I have put all of this code into this SQL files, and you can say that so this is the schema. Basically, this is the schema we're going to use at the moment. We're going to create a bunch of tables, and after that, we will try to insert into the database. So first, we need to create a table called mode, and then we need to connect to the table PSQL mode, and then now you'll see there's nothing in here. So what we want to do is that we want to run the SQL. We want to run the data definition language, which is the SQL, which is the schema. So specify the database and then file handler, and then we need to do the schema. We need to run a schema first, and then it will create a bunch of tables for us. And then we can actually connect to the database. So PSQL mode, and right now you see that we have some tables, but we don't really have any tuples. You see that? I didn't put semicolon, and now it is waiting for me to complete the semicolon. Now there's nothing here, so let's use the data manipulate. Let's insert these values. So okay, so this is very interesting because every insert 01 shows you that the tuple has been successfully inserted, and every time it's complaining, it's because we're violating the constraint of the schema. So here it's saying that you cannot insert the row of Andrew angry because angry is not a legal mode defined by our database, because this is a enumerated type and it can only take after either sad or happy. And for Tina is also rejected because let me see if Tina is rejected. For Tina, I feel like Tina is not rejected. Let me look at the real database to know for sure. So we're gonna look at people. So Tina is actually here because we're not saying that the mode needs to be not empty. And let's look at let's try another one. So what if I want to insert into the people's table, and then I'm going to specify values, Jerry, happy. If I do that, it should go through. And if I do Jerry angry, it will not go through because angry is not a valid input value for the enumerated type mode. Okay, so let's look at how we can do update as well as delete. So how do we update John's? How do we update Tina's feeling? So what we can do is that we can update and followed by table name, and then we need to set the field, which is fields here, to either a constant value or an expression. So here we're just gonna put a constant value, so which is happy. We want to make Tina happy, and then we want to specify where is this update taking place. So we're gonna say that this takes place where name is Tina. Okay, and now it should change the value of Tina to happy as well. And let's do the same for Annie, and maybe we make her sad. Okay, maybe we make her sad. Okay, so this is how you delete tuples, and this is how you update tuples. And for delete tuples, what you want to do is that let's just delete the Annie here. We want to delete the person who is sad. So we want to delete from table. Table is basically people, and then we want to specify where we're deleting from. So we can either specify where fields is sad, or we can specify that name is Annie. So we can specify fields is sad. We delete the tuples where the feeling is sad. Okay, and after that we've only got three tuples left. And if you don't put the where conditions here, it will just automatically match all of the tuples in the table and delete everything. So if you don't precisely specify the condition, everything will be gone. So you can see that the people's table is now gone. Okay, So another thing that could be interesting for this part of the lecture is that in each, for instance, in the student enrollment database, every time you declare something as the primary key, you will see that it automatically enforces it is not only not empty but also unique. So if you declare something as a primary key, um, you you see that it is not only not empty but also unique. Let's demonstrate that real quick. And I'm going to show you where to find this SQL file so that you can do this exercise step by step at home. Let's see if we have created the student. Let me drop this database first. So drop mode and drop. Uh, Let me see if I have student database created. Yes, we have that. And let's look at enrollment. Um, let's look at student first. Student, and we got 3 students, Jack, Bill, and John. And what is the structure of students table? So we got ID, name, and degree, and here ID is a primary key of this table, and they have already created a B-tree index for the primary key. So the B-tree index is very good for range queries as well as exact matches, and that is why a B-tree is selected as a data structure for the primary key index. So you don't have to understand how it is created and where it is stored at moment. You only need to understand that the index makes retrieval a lot faster on the primary key field. And another thing that we want to demonstrate is that once you declare something as a primary key, it is automatically unique and it is automatically not null. So let's demonstrate that it is not, it is definitely unique. So let's just say that I want to insert something into students table, and I want to say the values is, let's just insert something, another student with the same student ID, with the name Jerry, and the degree is 1650. If you do that, it will reject you because this is a duplicate key and it violates the unique constraint the primary key imposes on the field. So as you can see that although we did not specify that that field, the ID field is unique or not, but just by saying it is primary key automatically guarantees that it is unique. Okay, so I will. Okay, that's the that's basically what we did in the lecture, and also another thing is that the bulk insertion. So a lot of times we don't, in order to create a database, we put a bunch of insert statements into a file, and then we just execute that SQL file, and um, that's how a database is usually created. And you see more of this when you're actually playing with the assignment. And another thing that's interesting is the pgdump command. So if you want to make an exact copy of your existing database, you can use pgdump to dump your existing database into one file, and then you can make that new copy to somewhere else, and then you can recreate that same database using the dump file that you have just created. And that's it for week 2 Thursday's lecture, and I will show you where to find I also make an announcement about where you can find these files as well. And until next time, um, have a good weekend.